Okay, so we're going to talk about inequalities involving absolute value today. So first thing we need to do is kind of go back and look at equations with absolute value. Remember when we had b inside of the absolute values and we said that was equal to 5, we had to break that down into b equals positive 5 and b equals negative 5, because if I plugged positive 5 in, I would get 5, and if I plugged negative 5 in here, the absolute value of negative 5 is also 5. And we did that for much more complex equations earlier this fall. And we're going to do it with inequalities today. So let's start with this example. M plus 2 less than or equal to 11. So I'm going to do m plus 2 less than 11. And instead of saying it's less than negative 11, I'm instead going to put a minus sign outside or a negative outside this parentheses and distribute it in that way, okay? So I'm going to have to distribute that negative. So that way I have a positive case and that negative case, okay? So let's go ahead and solve my positive case because that's pretty easy. I'm sorry, we shouldn't add 2, we should subtract 2 off both sides. M is less than 9. Over here, when we distribute that negative, I get negative m minus 2 less than 11. Now I can add 2 to both sides. Negative m is less than 13. I divide both sides by a negative. When I divide by a negative, my sign flips, and I get m is greater than negative 13. Okay? If I were to graph these on a number line, here's negative 13, here's 0, here's 9. We know that m is less than 9, open circle line going this way. We know it's greater than negative 13, line going this way. And I know that this is an intersection. I'm going to do one more with you before I turn you loose. Let's do the absolute value of y minus 1 less than negative 2. So I have my positive case, y minus 1 less than negative 2, and my negative case, where I'm going to distribute that negative sign through. Okay, over here I add 1 to both sides. I get y is less than negative 1. When I distribute this minus sign, I get negative y plus 1 is less than negative 2. I subtract 1 on both sides, and I get negative y is less than negative 3. I divide by that negative. So I get y is less than 3. And I go to graph that on a number line. Here's negative 1, here's 3, 0. And I can graph that, and it graphs like a union because they don't necessarily intersect. But I've missed something really key here about absolute values. And the fact is that an absolute value can never equal a negative. So why on earth would an absolute value be less than a negative? Notice that's different. Over here we had m is greater than negative 13. That's okay because positives are greater than negatives, and it can be greater than negative 13. But when I start out by saying it is less than a negative, I'm going to run into problems. And so even though this graph is a union, because this original statement was not true, when things are not true in inequalities, remember we say that's the empty set. Okay? If you don't remember the empty set, please go back and watch the video that discussed the empty set. I believe it was the solving multi-step equations. That seemed to be something that we may have struggled with on the quiz. And so just go back and look at it and review what an empty set means. It means that what we're doing is not true. Okay? So let's try some on our own. First, we'll try the absolute value of n minus 8 less than or equal to 2. So go ahead and try that. Take a minute, pause it if you need to make sure you got that n is less than or equal to 10, but n is also greater than or equal to 6, thus giving me that intersection. Okay? And then we'll try this next one. Absolute value of 2c minus 5 is less than negative 3. So go ahead and try that. Before you start working it out, make sure you stop and think. It's less than a negative. Therefore, I'm going to get the empty set. If you showed work beyond that, you better make sure you go back and check to make sure you're not having something that's less than a negative to begin with. Okay? Let's try another one. It's not less than or equal to a negative, so we're good for not having an empty set. We just want to know, is it a union or an intersection, and how we solve from there. So go ahead and try this on your own. You should get x is greater than or equal to 2 and x is less than or equal to 6. If you need to take a minute and make sure your work is correct, go ahead and do that. When I graph these, I get closed circles on both 2 and 6, but the arrows point away from each other, thus signifying a union. Okay? If you want an extra example, go ahead and try this last one. And then after that, I guess we'll be done. Okay, so last example, here we come. R minus 6, the absolute value of r minus 6 is greater than or equal to negative 5. Now, just because I start with that negative doesn't mean I'm going to automatically have the empty set because I'm greater than or equal to 5 right now. So go ahead and solve. So if you solve it out, you should get r greater than or equal to 1 and r less than or equal to 11, which graphs as an intersection. Thanks for watching.